right? So is it fine? I think so. We'll start HEC-RAS. So what we have done, calibration we have done. We are taking some events, so we have calibrated that, and using those calibrated parameters we have did validation. So if the performance was good in both calibration and validation, using those parameters we projected the future. We projected the simulated flow for the future period, right? Now in this class we will see with that future projected flow, so how the flood is moving. Is it inundating the places nearby or not, or is it like what is the depth of that flow? This is the first. So this is called, we have seen in the last class, precipitation, how the infiltration classes. So we have three methods, right, to convert precipitation to runoff. Loss method, which calculates all the losses, infiltration loss, canopy interpretation loss, all those losses. Then the transform method will give you the direct runoff hydrograph. After that, this Muskinger method will give you the direct runoff hydrograph, routed direct runoff hydrograph. Then if you add base flow to that, you will get stream flow. So now our interest is this. So after reaching the water from surface to the stream, so our interest is to know what is the depth of that stream, what is the depth of flow in that stream, and how extent it is going when the peak is coming, okay, and how on which velocity it is moving, means how fast it is moving in the stream. So these three we are going to address now. What is the depth of flow in the stream, what is the velocity of the flow, and at what extent water is moving. So I'm just triggering some points before I'm going to continue the HEC-RAS. So this is the watershed. So all those are water coming and entering into the stream, right? We just take that small part. I'm just keeping that here. So this is a plan view, okay? So these are two cross sections, AA and BB. One is cross section view and another one is profile view. So this in the cross section view you will get to know the depth, means top width, all those geometry you will get to know. In the profile view you will see the slope. You can find out this is the way you can find out the slope, and also we can find out the velocity. So coming to HEC-RAS, so to find out these hydraulic parameters, depth, flow and velocity of the stream flow, so we require hydraulic model. So HEC-RAS is one of the hydraulic model, so which is Hydrologic Engineering Center River Analysis System, which is developed by same US Army of Corps, and it is designed to simulate and analyze the river hydraulics, and it is a key tool for understanding the water levels, means depth, velocities and river hydraulic parameters, and it is openly available. It is open source, and in using HEC-RAS we can do 1D 2D modeling and 1D 2D interaction modeling. I'll tell you what is 1D, what is 2D, and also we can perform both steady and unsteady. Steady means what? The parameters are not changing with respect to time. Unsteady means the parameters are changing with respect to time. So whatever the flow we are getting from HEC-RAS, HEC-HMS, that flow is changing, right? We are getting that 31 days event duration, the flow is not same. With respect to time it is changing. So that is unsteady flow, So we will do both steady flow and unsteady flow in HEC-RAS. And this is, we are limiting to 1D because it will take more time for 2D and all. I'll explain. This is just, I just kept my handwritten this one, don't mind it. So I just want to explain. See, the first one was plan view of the river. So water move along the direction of the river, right? So then water will, like slowly water will increase the depth in the stream. Then if it reaches the maximum level, then water also will move into the floodplain area, right? So water is moving along the direction, and also it is coming from in the z direction from here to here, and also water is moving in another direction. So the water is moving in 3, not in 1D and not in 2D. But anyway, this direction will come only when fill this water. So we are mainly focusing on along the x direction how the water is flowing, and in the y direction how water is elongated. So these two we will consider. This is same. It is the difference between 1D and 2D. So if you focusing on only along the direction of the river, then it is 1D. If you are focusing on both along the direction of the river and in the in all the directions, longitudinal and latitudinal direction, if you focus, then it will be 2D. Okay. Same. In 1D HEC-RAS, the flow is assumed to be vary only in the longitudinal direction, means along the river, and at each cross section the flow is assumed to be same, uniform. And then the 2D HEC-RAS, the flow is allowed to vary in both longitudinal and latitudinal directions. So this we can done by creating some mesh. I will tell you. So when to use 1D and when to use 2D. For example, in your case, if you want to focus on how the flow is varying along the direction of the river, then you have to go for only 1D. For example, if you are focusing on the river study, river basin, if you want to see like along the river how the flow is moving and what is the inundation happening just in the floodplain area, then you can go with 1D itself. Suppose if you want to do urban floods, in the suppose urban drainage management, so how water will move from higher elevation to lower elevation. It won't only move in the river, it means just in the one flow, right? So wherever the elevation is there, elevation less, so water move in all those directions. So if you are looking in that aspect, have to go for 2D. If you are looking only in the river, along the direction of the river basin you are studying, then it is 1D is sufficient. Okay?
Sir, it is HEC-RAS, river resistance. Will it be applied for urban flood only?
Yeah, that's what I am telling. HEC-RAS can be done using 1D and 2D. In some places you will get to know the river is also going within the main city, so you have to do both 1D and 2D. That both both also you can do. But interaction is also there in HEC-RAS. You can perform 1D 2D interaction also. Yes. Yeah, that's what it was upgraded. Initially it was 1D was there, then it came to 2D, then it came to 1D and 2D interaction also. So this is the interface of the HEC-RAS. Understood, right? What is 1D, what is 2D, when to use 1D, when to use 2D. So this we can done using this software called HEC-RAS. So this is the interface. So these are the three main, I can say three main windows in the HEC-RAS. So this is the main interface. In this you will get so many options. So one of the main option is creating geometry of the river, geometry data, and next one is that is also it is a subset of the geometry, RAS mapper. So what we will do in that is we don't know exactly like how the river is going, right? So in using the RAS mapper is nothing but is a kind of GIS layer. Okay, you can upload your DEM, or you can upload in there you can also see Google satellite maps. So if you see here, this is Google satellite map. So in the Google satellite map, using this, we can identify that this is the river, this is how it is going. So based on this, we can we can draw these lines, like how the river is going, all those geometrical data. This is called geometry of the data. We can draw using RAS mapper. Okay, so that will reflect in this geometry data. We will get to know once we are doing. You will get to know clearly. So same like in the HHMS also we are having four main files. Here also like first one is project file, which contains the information about the project, and second one is geometry file, which is very important. Here you will get what is the river cross sections and how many cross sections are there, what are the width of the river, all those geometrical information of the river will be stored in the geometry file. When you suppose after creating the project, in your folder you will get all these four files. So the flow and study it is one of the important file. So here we will mention the information about our discharge. Like either you want, if it is a study flow, we will mention that study flow information, that value. For any study, if it is any study, we will mention about that any study along with some parameters are there. I will tell you. So all those information will be stored in this file. And this is plan file. The plan file is nothing but you want to run, like it is something like the control specification file. In this, that information, like from which period to which period you want to run and what parameters you want to use, all those information will be there. Yeah, this is one of the RAS mapper explained already. Yes. See here in this RAS mapper, this is how we need to draw the lines. So this is this blue line indicates center line of the river. This red lines are bank lines. Just it will so that model will understand this is the bank of the left bank and this is the right bank. So it will calculate the distance of the left bank and right bank. And this line indicates the floodplain area. So how much floodplain area is there? What is the probability of so it is just our assumption flood may go up to this line. So that line we need to draw. It is an approximation line. So if flood is going to that point, it will go. Otherwise, all these geometries we are drawing so that when we throw the flow here, it will reach up to these cross sections only. For example, if you are limiting these cross sections up to here, you will get the flow up to here only. That's why when you are drawing these lines, it is better to create with more gap, so that till that there is a chance of going there. The flow is going there, it will predict. Otherwise, it will. You will see when we are doing. You will see that. So understood? Blue line is center line, red line is bank lines, and next line is flow path. Flow paths. So the maximum extent of flow can go, and these are cross sections.
Excuse me. Why we are dividing into so many cross sections?
So see, what HEC-RAS will do is, it is like how we did in HHMS, dividing entire area into subbasin. So it will do all the calculations subbasin level, then it will go to the next slide. Same. It will identify the depth here, then it will go here, then it will go here. So these many times model will run till the last point. So how many cross sections are there? That much accurate it is. No, we will give continuous. Yes. When we are doing it, we will let you know. So this is about just center line. So, but cross sections, when you are drawing cross section, this cross section should cross all the lines. Okay? And if you see here, when you are drawing these cross sections, it should touch all the 4 lines. And this cross section should be perpendicular to the main river. Try to keep it perpendicular to the main river line in center line. And always if I am saying, for example, if I am standing here, this is my upstream, that is the downstream. So this will become left, this will become right. Right? So when I am saying left bank means, assume that you are in the upstream side, this is left bank. So if it is a upstream, so this will become left, that will become right. Okay?
So all the cross-section lines will be perpendicular?
Yeah. You keep maximum, try to keep it perpendicular to the main river. And they should not intersect each other. Okay? Yeah. So after running it, you will get the levels at each cross section like this. At each cross section, what is the water level, what is the depth, what is the extent, everything you will get to know for each and every cross section. And this is the unstudy flow, how to give. This step you will get to know while doing. and finally you will get the result like this. Okay, how the flood is inundated the places here. Okay, understood? And I want to tell you one more thing. Small thing, don't confuse. So how it is, suppose we are giving flow, right? So how it is getting calculated depth at each and every cross section. So it uses Saint Venance equations, both continuity equation and conservation of mass. This continuity equation is nothing but inflow is equal to outflow. If any losses are there, that one. Conservation of mass will try to what we can say, balance the forces. So our one is it will go through water will move through gravitational force, right? So what is the opposite force? Frictional force. So it will balance the both. So in simple, what we can say like this. So your continuity equation there, right? So for example, Q equal to area into velocity, right? So Q equal to area into velocity. V is nothing but velocity. It can be calculated by using Manning's equation, 1 by n r to the power of 2 by 3 s to the power of 1 by 2. So, but I'll tell you one thing, like how it calculates. It is important. So this is the point. Yesterday in the HMS, this is the outlet. If you see that full figure, you will get to know. This is the outlet. So here we simulated the flow. So now we will give input here. So it will come like this. Okay. So it will but we don't know at the end what is the flow, because when we are doing it, so we have to identify the boundary conditions. So first one is for upstream flow. Downstream we don't have any flow, right? But what we will do, we will apply normal depth concept, means we will assume that the flow is moving normally, means uniformly. So we will assume that whatever the water level here at the downstream point, they are following the bed surface slope. Bed slope here, so we will assume that bed slope is equal to the friction slope. So from there, we will identify the friction slope, S value. So if you keep that slope value in the Manning's equation, 1 by n r to the power of 2 by 3 s to the power of 1 by 2, if you keep S there,
velocity.
it will give you the velocity, right? But we don't know the depth, right? We don't know the depth. So velocity is a function of depth. Because V equal to 1 by n r to the power of 2 by 3, r means radius, hydraulic radius, A by P. But area, we don't know. You just know the width of the river, we know. But depth of the river, we don't know. So velocity is a function of depth. So, but we are assuming that it is flowing uniformly. We will know the Q. So Q equal to area into velocity. We will find the depth. So, but that depth may not be, for example, but it is not uniform, right? But it is not uniform, because the energy at one cross section and energy at second cross section is not same. In between, that loss of it will be there. So what will happen? It will back calculate it. So here you will get Q. It will again go back to the first Q. If it is matches with the first Q, then the depth is fine. Otherwise, it will again come to here. It will change the depth. So it will. So this is the infinite process. Something finite. This is finite difference method is happening inside. So that is what it will happen inside.
Considering the meanders, we need to undertake the angular velocity also, right?
Yes. Momentum also it will consider. Yes. So that is what happening inside. So until it is matches with the first Q, it will try to iterate that many times. Then it will throw you the final depths. Okay. Based on that depth, we'll see the inundation. Okay. So now we'll start doing it. So all of you open HEC-RAS. All of you open. This is the small window. Don't. That's it. Okay. This is a small window. The first step is what? Usually what is the first step? You need to create the project, right? Same step. First step, creating the project. For that, just go to file. All of you follow with me, okay? HEC-RAS will get so many errors. Just follow with me. If you are stuck at any point, immediately you call me, I will come and I will do. Okay? Go to file, create new project, click on new project. Yeah. Here in this box, see here. Here you can choose the folder where you want to save the project. Okay? Here there is option, you just click here, save it wherever you want. Just select that folder. It is better to save the where the data is there.
Last time's data only.
Yeah, same last class data only same. I'm not using anything. Same last class data only. So, if you want to create a folder here, you can create it by clicking here. If you want to create it, otherwise it's fine. You can directly save in the main folder. So after that, after selecting the folder, just type, give the title name. Don't give with spaces. Always any model, better don't give any spaces while creating the name. So I am giving just T1. Just click OK. Yeah. If I am going speed, you just ask me to stop. I'll stop. Just if this window is coming, just click OK. Just click OK. So all of you reach here. So next step, actually mine it is already in SI units. So if I think yours is in US metric, US customer units. So to change it into metric, go to options. Go to options. Go to options. Here option is there. unit system. Change it to system, international metric system. Just click on this. If you want to click select this, next time onwards it will come in the SI units itself. Okay? Just click OK. Now whatever the units coming from that, whatever the data which is coming that across, it will be in SI units. Options. Now you check the right corner, it is in the SI units or not. Right? All of you reach here? Just save it. Just save it. So next step is creating the geometry. Okay? So to create the geometry, click on File. Sorry. Click on Edit. Click on Edit. Click on Geometry Data. Click on Geometry Data. Just save it. Save this geometry, empty geometry. Go to File. Go to File. Save geometry. Just name it as geometry. Yes. Save geometry. Click OK. So in this geometry, here we need to draw the river center line, bank lines, and flow paths, cross sections, everything we need to draw here. Previously, when the HEC-RAS started in the first version, there is no GIS layer inside the HEC-RAS. Now, in the newer versions, the GIS it was included in the HEC-RAS. So that is nothing but RAS mapper. So using RAS mapper, we can draw all those lines. Then all those lines will be visible here. Okay. Otherwise, like it is difficult to know what is from where to where the river is going. All this. So using so just close this. So we are drawing the geometry using the RAS mapper. Okay. Here, this option, this layer option, that is open RAS mapper. Just click on that. Right? All of you reach here. Click the RAS mapper. So it is like our GIS layer. So first to see all our rasters, we need to set this to projections. Okay, we need to assign coordinate systems to this. So first step is setting projections. So for that, go to project. Arun. So click on set projection. Click on set projections. Here we need to choose. In the HEC-RAS what we did, we mentioned right 43 and like that we mentioned. But here there is no option like this. So what I have done is we need to create a shapefile with projections. So whatever the HEC-RAS file we have that we developed, I told you right, we can export the shapefiles from that HEC-RAS. In the same way, I exported. So if we export any layer which is already projected, so the exported layer is also same projections. So we are just using that shapefile We are just taking the projections from that shapefile. Okay? I already given you that shapefile. Go to file, not this one. Whatever, same. HEC-RAS also will give you one .prj file. Don't select that, okay? Go to Netravati data, this PRJ file. Just open this folder, select this .prj.
We don't have
This one don't know.
What is that?
Okay, I think he has shared now that projection file in the WhatsApp. You just download that. See, when you create any shapefile, it will be with multiple files. .prj, .shp, .su, something, all the files. In all those files, we are just taken .prj. In that file, it will be all that projection system will be there in that. So we have chosen. I just take only that and I just copy pasted here. Okay. This data is not with you. Any shapefile which is having 43 and not, you can use that. This file is not reached to you.
So you shared in WhatsApp group.
I shared this. Download it from WhatsApp group. Na? It is there in the. Otherwise, there will be one more projection file in the yesterday. Like last time we have run the HMS, right? So in that also .prj file will be created. You can use that project file. Okay? We just taking the coordinates. Okay? Anyone got stuck here? People are done? Done? Not done? Yeah. Okay, people done now? Got that file, right? Understood, right? Why we are selecting this? Don't have option to enter the 43 now. We are just taking the shapefile which is having the same coordinates. We are just assigning it. Click on open. Sorry, select. So here you will get to know the projections of that shapefile 43 now. Okay? I just simply assigning the coordinates. Done? So click on apply and OK. Click apply and OK. Alternate files are all of you reach up to here. So now we have assigned the projections to the map layer. Now we need to give the DEM to the model. Okay. So to give the terrain data, go to project, click on project. Here option create new RAS terrain. Click on that. Create new rash terrain. Here, this plus symbol. Plus symbol, it is not about add data. So just click on this plus symbol and choose the dem file that is there in the Netravati data. Just choose the dem file, raster file. Okay. Next, click create. So it will take a couple of seconds to load the dem. So terrain came. Till now no error, right? Everyone got terrain. Just close this window. Now you can see this is our study area. Yesterday, using HEC-RAS, we have simulated the flow till somewhere this point, right? So we don't know exact the location of that point. So to identify the location, we have to add that outlet shapefile here. Okay? So for that, click on project. Click on project. Here option is there, add layer. Click on project, add layer. Then choose in the Netravati data, Netravati outlet. Choose this shapefile, open it. Now you can see in the map layer where the outlet is there. So in our case, that is upstream. Now we are looking at the what is happening downstream of that location. Okay? So what do people do? Zoom to that particular location. Zoom the map. Let's see here. Zoom like this.
Project and last. Version 6.1 है.
All of you reach here. Now we'll add our Google satellite map and see really that flow is matching with the same our dem or not. Okay. To add that Google satellite image, just right click on this map layer. Right click on map layer. Option is there, add web imagery layer. All are connected with internet, right? Yeah, if internet works, then only it works. Okay. Then choose Google satellite. Google satellite or Google map. Click OK. See, our point is here, right? So if you don't have that, like, you can also, using this also, you can draw the center lines and flow paths. Understood? How to add Google satellite map?
Once
So, just right click on this map layers, add web imagery layer, just select Google satellite and click OK. So this is important after getting the, after running this model, you will get flood inundation map, right? So you can able to see like water inundation. Okay? As of now, you just uncheck it. Uncheck it. So next step is to draw the center line of the river. Okay? To draw the center line of the river, see here, 1 minute. First to see how I am drawing. Okay? Then you will do it. Otherwise, it will be some, you have to do it very slow. First time you are doing. So first you see me how I am drawing, then you do it. Okay? So to draw the center, first to draw the center line, first activate this, click on geometry. Then the first option is reverse, right? Yeah. So just you need to right click here, add geometry. See here. Okay. You have to draw the center line like this. For example, when I am drawing, it went like this. Okay, simple. You can just click Ctrl Z, it will come back. Okay. So just click here, reverse, geometry data. Now it is already started. So just click somewhere below this point, not above that point, because we have the data below this point. Okay? Right click, edit geometry, then start below this point like this. Slowly draw the main river, it should pass through the center. No. Click on river, edit geometry. Right click, edit geometry, then slowly draw up to that point. Zoom in, sir. These lines are important. Draw carefully, okay? Mostly errors will come here only. So, yeah, there is no, like, End point we don't know. You can stop somewhere here. Okay. Is it fine if you went forward also? Is it fine? We don't have end point because we don't know the downstream boundary, so you can drop it somewhere else. After drawing that, just double click it. It will ask you to save with each one. Just click yes. Okay. Yeah. See, it should be only one reach. River one, reach one. Suppose if you if you give the brakes, now it will show you reach one and reach two. Okay, don't give brakes. It is a continuous line. Okay, but it is continuous. It's not a single line. Yeah. River one, reach one. Okay, save it. Click OK. All of you reached here. Anyone any doubts? Any stuck? Okay. Zoom it to the right corner. You just zoom it down. Still zoom it. Okay. So for that, click on project. Click on project. Here option is there, add layer. Click on project, add layer. Then choose in the Netravati data, Netravati outlet. Choose this shapefile. Open it. Now you can see in the map layer where the outlet is there. So in our case, that is upstream. Now we are looking at the what is happening downstream of that location. Okay. So what you people do? Zoom to that particular location. Zoom the map. Let's see here. Zoom like this. Further. And last. Maybe version 6.1 है. All of you reach here. Now we'll add our Google satellite map and see really that flow is matching with the same our DEM or not. Okay. To add that Google satellite image, just right click on this map layer. Right click on map layer. Option is there, add web imagery layer. All are connected with internet, right? use Google Satellite? Google Satellite or Google Map? Click OK. See, our point is here, right? So if you don't have that, like, you can also, using this also, you can draw the center lines and flow paths. Understood how to add Google Satellite map? So, just right click on this map layers, add web imagery layer, just select Google Satellite and click OK. So this is important after getting the, running this model, you will get flood inundation map, right? So you can able to see like water inundation. Okay. As of now, you just uncheck it. Uncheck it. So next step is to draw the center line of the river. Okay. To draw the center line of the river, see here. 1 minute. First see how I am drawing. Okay. Then you will do it. Otherwise, it will be some. You have to do it very slow. First time you are doing. So first you see me how I am drawing. Then you do it. Okay. So to draw the center, first to draw the center line, first activate this, click on geometry. Then the first option is reverse right. Yeah. So just we need to right click here, add geometry. See here. Okay. You have to draw the center line like this. For example, when I am drawing, it went like this. Okay, simple. You can just click Ctrl Z, it will come back. Okay. So just click here, reverse, geometry data. Now it is already started. So just click somewhere below this point, not above that point, because we have the data below this point. Okay. Right click, edit geometry, then start below this point like this. Slowly draw the main river. It should pass through the center. No. Click on river, edit geometry. Right click, edit geometry, then slowly draw up to that point. Zoom in, sir. These lines are important. Draw carefully, okay? Mostly errors will come here only. So, do. there is no like end point, we don't know. You can stop somewhere here. Okay. Is it fine if you went forward also? Is it fine? We don't have end point because we don't know the downstream boundary, so you can plot it somewhere else. After drawing that, just double click it. It will ask you to save with each one. Just click yes. Okay. Yeah. See, it should be only one reach. Bigger one to each one. Suppose if you if you give the brakes now, it will show you reach 1 and reach 2. Okay, don't give brakes. It is a continuous line. Okay, but it is continuous. It's not a single line. Yeah. River 1, reach 1. Okay, save it. Click OK. All of you reached here? Anyone any doubts? Any stuck? Okay. Zoom it up to the right corner, you just zoom it down. Still zoom it. Done. That's what you cancel it again. It should be continuous reach. If it is creating twice, means reach 1, reach 2, you just click Control Z. It will come back. It should be only one reach. Reach 2 means again it is a second river. No. It is fun. Actually, for example, if any tributaries are joining in between, so that you can consider it as a reach 2. So again you have to draw the center line for that tributary. Suppose for example, any tributary is joining here. Okay, again you just click or draw one more center line. So that will be act as a reach 2. So those two we can connect it to junction. Okay. Understood? So now we have drawn this center line, right? We need to save this. So to save this, just right click on this. It is asking stop editing. Click on stop editing. It will ask you to save. Click yes. Okay? Then after saving it will be in blue color. Okay? All of you reach here? So now we have drawn the center line, right? Next step is to draw the bank lines. So that model will understand what is the left bank width, right bank width. Okay? So to draw the bank lines, here, right click here, same way. First see here, I am drawing it, then you practice, then you do. So edit geometry. Okay, it should come close to this point, this layer. Understood, right? By seeing this, you will get to know, right? This is the back line. So draw the same line, like that. See here. Okay, left one is done. Just double click it. Again, you come to right one. Same way you can do it. And then double click it. Do it slowly. Same, if you are done any mistake, you just Control Z, it will go back. And forgot, always draw from upstream to downstream. Okay, don't draw from downstream to upstream. Always draw from upstream to downstream. So the model will calculate the slope of the each cross section. Next we are doing the step. So it will calculate the same. In the same way it will calculate the slope. So after drawing these lines, model will calculate the distance between the center of the river to the left bank, center of the river to the right bank. Right click, save. Stop geometry, stop editing, save. Note 2 lines should intersect. Okay? It is done. All of you reach here? Yeah. For example, if you want to edit after drawing this line, if you want to edit, if you want to adjust the line little bit, just click on this option, edit features. Okay. So after clicking this, just select which line you want to edit. Just click on that line, double click. So all those connections are enabled. You can just adjust. For example, this you want to adjust, you can adjust little bit like this. Okay. If you want to adjust, you can adjust little bit like this. Then after that, you just double click it. Okay. That adjustment you can do. Don't save again. That's one more thing. It should be a continuous line. It should not be any breaks in between. Okay? If it is break, again it will throw error. All of you reach here? So our center line is done. Bank lines are done. Next, flow paths. Flow paths, nothing but we need to draw the lines considering the floodplains. Okay? Save, just save these lines. Stop editing, just click save. So these lines are saved. Next one is flow paths. Same, right click it. Edit geometry. See here, it is an approximation line. Okay. So we are assuming that up to this is the floodplain area. First, always better try to draw from left to right. Because it will always calculate, model will calculate the first line was left line, the second line was right. So it will assign the distances in that way. So double click, same. The right also same. Just double click it. That's it. That's what we are assuming that. So if you open the Google satellite map, so till that for every river they will say that from here to here this is the floodplain area. So based on that width we can draw those lines. Okay. I can draw I will show you. Like if you draw the flood, when you are drawing it should be meaningful. Right? Wherever the river is going in the same direction, flood plan is also just you will also follow the same river path. For example, if you got that shape file from from government departments, you may get the floodplain area shape file. So you can import that shape file, and you can, by seeing that shape file, you can draw those lines. Okay. This is upstream. This is our downstream. So this will become like this. This will you will see the direction of the flow. Then we have to decide left or right. Yes, yes. All of you reach it up to here. Save it. Save. Right click. Edit. Stop editing. Stop editing. Save it. Okay. So next step is drawing the cross sections. So there is no limit. We can draw only 5 cross sections, 6 cross sections. It is not like that. For example, if you want to assess, when you are doing this for in the river basin, if you want to assess what is happening in each and every 500 meters, then you can draw the line cross section at each and after 500 meters. Okay? There is no rule, but how many cross sections are there? It will calculate for each and every cross section till the downstream. So just see here, first see here how to draw the cross section. So the cross sections, 2 rules are there. First thing is, you should draw from left to right, and it should intersect all the 4 lines, all the lines, and try to draw that line perpendicular to the center line. Okay? All these 3 should be keep in mind and draw. First see here how I am drawing, then you draw. Okay? Same. Cross sections, click this. Right click, edit geometry. After drawing one cross section, you just double click it. Again. Yeah. Understood? That cross section will give you the shape of the river. We will assume that depending upon the cross sections only, nothing but it will flow, can't go beyond these lines. So after getting results, you will get to know that whatever even the inundation is out of the cross section, it won't show you. That's why when you are drawing the cross sections, you have to try to cover the possible area of the flood. Okay? We'll see. Now, when we we are creating cross sections by drawing this line. Yeah, so once you draw this line, then with the help of them, the cross section will form. Yeah, not immediately. You will get out. Yeah. That's what. It's all you should require information from the river. They'll tell you that this is the possible flood area. So based around that distance, you draw the flood area. That's what based on our cross section distance, flood will go up. That's why when you are drawing cross sections, it is better to draw the full line. The maximum nothing will happen. So till that point will go. Water is moving where up to which distance water will go up till that point will go. But if you are drawing this cross section, water will be moving to the point. We need to give in the master format. Actually, what will happen when you are drawing this cross section, right? So at each and every point, it will require the elevation. So you have to get those elevation in the format of master. Them point elevation. Understood, right? The importance of cross section.
How the slope is, what
It depends. Yes. Jump 10 meters or 5 meters. It will not be same. Only in the middle river, higher elevation. In the floodplain, lower elevation. Done now? Done? So, while drawing these cross sections, so these cross sections will give you river shape and length and width. Okay. So when you give the data, water cannot move beyond these lines. Okay. When you are drawing the cross sections, you give in such a way that give in a maximum distance. Okay. That will fix the, for example, the water is going, in a real case, water is going beyond the distance, beyond this line means. So this whatever the analysis, you won't get that line. You will see after the results. So water will be limited within these cross sections only. Okay, when you are drawing cross sections, you draw as much as you want. So that water have flow, like it's have free flow to all the way to go. Okay? Understood what I mean to say?
Yes.
Water cannot go beyond this thing. Okay? When you are drawing the lines, you draw the big lines. Shall we proceed? Same. Right click, stop editing. Geometry, just save it. Then just go to file, save it. Done? Okay, with this our RAS mapper work is done. Huh? Yeah, save, just stop editing. it will save. Then just go to file and save it. That's it. Just save it. Now automatically model will take this geometry into the geometry file. Okay, just close this. Just close this. Go to edit. Click on geometry data. Here all those cross sections will be visible. For that you need to do one step. Yeah. Click on view. Click on view. Click on this set schematic plot extents. Set schematic plot extents. Click on view. Go to edit. Click on geometry data. Go to view. Click on this set schematic plot extents. Just click on set to computed extents. Click on set to computed extents. Click OK. If anyone, like, their terrain is also coming, huh?
Rafi, what is
For
the
anyone?
elevation? What is the number?
You just sit down.
What is the
Yeah, I'll tell. If here terrain is visible, if anyone getting into terrain,
yes.
you can just go here. You just uncheck this. The terrain is visible means here it is checked. You just uncheck this, and only cross sections will be visible. Okay? Here these lines are indicating cross sections. Okay? All these are indicating cross sections. These red dots are indicating bank lines. Okay? This is our center line. Again, you just set to X and do it. Okay? So this is showing the distance. This 523, 1291. All these are distance from the downstream. Okay. So I told you now, first it will take it the normal depth concept at this, then it will go to this, it will come like this. So it is 523 meter distance from above this. Then it is 1291. Like this indicates the distance. Check in your. It should be only one river, only one bridge. That's what distance.
Like
Distance from downstream. Last point. You will go from downstream. 0, 500, 1000, 1500. You will go from downstream. Yeah. All of you reach here? Any doubts?
Flooded region. Area of study.
Then save the geometry. Just go to file and save it. Now, here there is option called cross sections, right? Just click on cross section. So this circle is showing, right? This is the pink color, first cross section. So it is highlighting the cross section view here. So here. Click on cross section. Okay. Understood? So, everyone. So this pink line, it is showing the first cross section line. So this is how this cross section is in the cross section elevations are varying. Okay, we have dem, right? So based on the dem, it is identifying how the elevation are changing in the throughout cross section. Okay, so like that you can see here there is option up and down. So next cross section, see it came down. Again next. So this is how the cross section is varying. The cross section elevations are changing like this. Understood? Here you can also see LOB, left bank distance from the center, ROB. So it will calculate the distance. And it is a left bank station, right bank station, and it also gives you contraction, expansion, all those parameters. Here next thing what we do is, along the cross section, we don't have the roughness coefficient value. So we will assume that along the cross section, same roughness. Okay. So usually what will happen? Roughness was less compared to the bank lines, means in the flood plains. Compared to flood plains, the roughness was low in the main channel, right? So that water will move freely. So roughness was more in the flood plains. So actually we have to get that data, okay, from authorities. But as of now, we don't know the exact surface roughness value, that Manning's N value. So we are assuming that we will give you the smooth roughness value at the main channel. Somewhat roughness means more roughness value at the bank lines. And we are assuming that throughout the cross section, that roughness was not varying. So first what you need to do is, here you can see, delete a cross section. While viewing it,
while you are viewing this cross section, if you find it inappropriate, how to
that includes everything means regarding geometry. We want to change the line, we want to change the everything. How to do it in the edit geometry. So RAS mapper.
start from the start from the
Yes, that's why when you are drawing the cross sections, it should be intersect with the 4 lines, and it should drawn from upstream to downstream. Okay, all these rules you should follow. After fixing everything in the geometry data, then only we come to here. Okay? So what I said, along the cross section, there is no, we are assuming that the roughness is same. So for that, here if you have the data, you can enter like each and every along the cross section at every point what is the roughness is there. But we don't have the data, we are assuming it is a uniform. So what we need to do? Select, this is something, one cross section selected, right? So here you just see here first. See here. There is options. Go to options. Here horizontal variation and n values. It is enabled. You disabled it. So just click yes. So that line will go here. Okay, that column will be emitted here. So in the same way, change the cross section. Disable it. Like this.
Can you once tell me?
Please go once.
Yeah. For example, see, we are assuming that roughness is same throughout the cross section, right? So we need to eliminate this column. Okay. So to do that, go to options. Here it is enabled. That's why that column is highlighted. Disable it. Click yes. Now you see that column is eliminated. So like that you do it for all the cross sections. Here, one by one. Once you cross check, have you done to all the cross sections or not? We are just we are not giving that radiation roughness value along the cross section. So you are eliminating it. But along the river, we should give. The floodplain also, what is that? Shall I proceed? You can assign that side. Mention just 0.005, 0.05, like that you can assign. Okay? All of you reach here? So next step is, we have removed this horizontal variation along the cross section, but we have to provide the roughness value in the main channel and the floodplain. Okay? Just save this geometry. And click on tables. Click on tables. And click on Manning's and any value. So here, if you know these are stations, cross sections. This is upstream cross section. This is downstream cross section. So if you know the Manning's value, means roughness value at all the cross sections, you can enter here. This N2 is nothing but main channel. So what is the roughness coefficient value in the main channel at all the cross section? N1 is left bank, N3 is right bank. Yeah. These are cross sections from upstream to downstream. This first one, Manning's and value. Go to tables, Manning's and value. Okay? So that variation is there, you can consider. Yeah. Yes. That, if you know the variation along the channel, if you know the roughness coefficient values at different cross sections, then we can assign those values. But we are assuming that along the river, in the main channel, only one roughness coefficient. So to give the roughness value in the main channel, here just select on that row N2, n equal to 2, just select here and then click on set values. I am assigning one value 0.035. You can give any number, means it should be smooth compared to the floodplain. So in the main channel I am giving 0.035 and click OK. So now it will assign all the cross sections in the main channel same roughness. Okay? Click on So next step. So this is at the main channel. Okay. In the left bank, in the right bank, same. Assume that it will be more roughness. So assume 0.06. The right bank also same. 0.06. So all of you reach here. Yeah, I'm telling you, na. So in the main channel, it is roughness. See,
N has to be roughness.
ah,
All the values are roughness.
all the three are roughness. N-2 is indicating the main channel.
And the
How
other
this?
two are banks.
Yes, the left bank and right bank. They are assigning same roughness throughout the main channel. 0.035. The banks, left and right bank, we are assigning the same roughness. Understood? Obviously, outside the main channel you have more roughness. So you have just given values like that. Okay? Up to here, clear? So we'll take 10-15 minutes break, then we'll start. Save it. Click OK, and then go to File. Go to File and Save.
Charge somewhere over there.
So, till now, what we did, we created the geometry and we have assigned the roughness in the main channel, the right bank and left bank, right? Now, what we need to do now, we have created the geometry and we have assigned the parameters. Now we need to flow the water from upstream to downstream, right? So our flow was unsteady, right? So we have simulated for the event. So it is changing with respect to time. So our flow was unsteady. Let's see both steady and unsteady. First we will try unsteady. Okay. Now next step is to input our stream flow data at the upstream to the model. Okay. For that is unsteady, right? So go to edit. Click on edit. Click on unsteady flow data. Okay. Click on unsteady flow data. So here this is the station at the upstream. This is the station at the downstream. So here we need to provide two boundary conditions. Okay. Our upstream boundary condition was our upstream flow. Okay, which was coming from the HEC-RAS. But we don't know the water level at the downstream, right? So we are assuming that at the downstream the flow was uniform flow, so it is following the normal depth concept. Okay, so there to identify the Q we are giving friction slope value. As it is a uniform flow, the bed slope will be equal to the friction slope. Okay, so area into velocity Q, in that velocity we are giving friction slope. So it is a function of depth. Velocity is a function of depth. We know the Q, so it will calculate the depth. Okay, understood? Our upstream boundary condition is our upstream flow, that is the simulated flow at the outlet of the Netravati basin. Then downstream condition is friction slope. Okay, so first we will give the upstream boundary condition.
Sir, could you explain the downstream condition again? Boundary condition.
What will happen in the downstream condition? We don't have the water surface level data, or we don't have the flow hydrograph, a simulated or observed flow hydrograph, or the downstream. So when we fit the model, we are fitting between two stations. So we are having data here, we are not having data here. So if we have the simulated flow hydrograph, you can give that as a downstream boundary condition. So we don't have that downstream flood hydrograph. So what we are assuming? We are assuming that downstream boundary, downstream last station is like it is the uniform flow happening. So whatever the depth, which is normal depth concept we are applying, that is nothing but continuity equation. So Q equal to area into velocity. So V equal to 1 by n r to the power of 2 by 3 s to the power of 1 by 8. So there we know Q, we know area means width according to this. So we don't know depth. So y is there. Again r means hydraulic radius, area by perimeter. So there also we don't know y. So and we know the friction slope S. So it will calculate that, it will solve that equation. Okay, entire equation. It will throw you one y value. Okay, like that it will go for the upstream. From downstream it will go for the upstream. At the upstream we have the Q value. It will, if that Q is coming correct, it is matching with that Q, then whatever the depth you are identifying at the downstream, it is correct. Otherwise, until that it will iterate, it will identify the depth value at each and every cross section. Okay?
In real time, we have two basic systems in the upstream, where we fix the upstream condition and downstream condition. In real time, if we have two basic systems in the one is in upstream, one is at the downstream. If we have the real time data, like say, for example, these many Q6, in upstream and downstream, that can be fixed. That can be given here.
That can be. That's what we don't have that downstream water level data. That's why we are going with indirect way. If you have that water surface level data or stream flow data or downstream, you can directly give that. There are multiple options, I will show you. There are multiple options. So for example, if you select here, the upstream, just click here, there are three options. Stage hydrograph, flow hydrograph, stage or flow hydrograph. Stage hydrograph means water surface levels. At that particular upstream point, if you know the water surface elevations over the event, you can directly give that water surface levels. If we have flow hydrograph, directly we can give flow hydrograph. We have simulated this flow hydrograph, right, using HEC-RAS, so you can directly give that. So you just click here. All of you have the output of HEC-RAS. If it is there, you take that. If someone system got shut down right in between, you take the observed data. Take the observed data. Open that Excel sheet. Go to file. Then enter all the data. Rainfall discharge. Yeah. So our third event is from 23rd. 23rd July to 22nd August. Right? Just select the flow.
Sir, which one is this?
2007.
Rainfall discharge best flow data.
Discharge. 2007 discharge. Yeah, overall total inflow. Total.
No, not. Sir, rainfall discharge.
Yeah.
A data, Rafi. Yes.
Whoever is having the HEC-RAS output, so there you will getting 4 columns, right? The third column was total inflow column. So you can copy that column. Or else you open that Excel file, that observation data is there. Observed stream flow data. The third event is from 23rd August, 23rd July. 23rd July to 22nd August. Select that discharge.
August 7th. Because this is August 7th. We got the month of yes, month, day, and use days. The dynamic load, which you have to bracket that.
23rd July to
23rd July. To August 20th.
Yeah. I told you to save in Excel and the total inflow column. So use that. Just copy that. That is we have simulated fourth column. Total inflow. The last column was observed. I'm telling you, whoever don't have the use that upload. Are you clear?
Date.
23rd July to 22nd August. That is the third event we have simulated. August 22nd August 2007. Just select that. 22nd August. 22nd August. Next month. Just copy. I'll tell you where to paste. Got the data, recharge data? Don't paste it now. Don't paste it, I'll tell you. You need to change the data. Just copy that. Done, huh? All of you go on the data where the input is. So before pasting it, okay. Now this window is open, right? So first we need to fix the time interval here, or start event time interval. So for that, you just click on fix start time. Click on fix start time. Here choose the date. 2007, 23rd July. Click OK. Click on fix start time. Open that calendar symbol and choose the date. 23rd July 2007. And here give the time. Yeah, before giving the time, you just interval give 1 day. We have 1 day observation data. Every day 1 day interval. Okay. After that, keep 24 here. 24 hours. Okay. Then just click on that column somewhere else. Now our calendar dates was starts with 23rd July 2007. Okay. Now paste here. So, I will show you how to paste. Select all the rows. Select all the rows. Then Control V. Okay. Here we did not mention end date. It will automatically take the dates. Okay. It will automatically throw you the 2 months data. Dates. So in the Excel, copy those, paste it here. Just cross check. Is it like 23rd July value is same and go to 22nd August value are same or not? You just cross check it. Yeah, you are taking from HEC-RAS. I am taking upload data. That's what. Select all the rows in the column and paste it. While pasting it, select all the rows. Okay. All of you reach here? Paste the data. All of it clear? Shall we move to next step? Okay, already copy pasted, right? Yeah. So at the end, if you want to plot, you can plot, you will get a hydrograph. Not required, just click OK. Okay? Next, you need to give the downstream boundary condition. As I told you, you have to give the slope, friction slope. So, the one way to find out the friction slope was, just see here. I am just first see here, then you will get to know. In the RAS mapper, there is something called measured distance, and scale is there. Okay, if you click on that, I am just showing. For example, if I want to see the distance between these two cross sections or slope between these two cross sections, you can directly start from here and end here. Just double tap it. It will show you the length, distance between the two cross sections, and it will also show you the slope. So one way to assign normal depth was, from here you take up to 5 or 10 cross sections, like up to 1 kilometer ahead. How many? 1 kilometer, 2 kilometer ahead. How many cross sections are there? Take up to that, then identify the cross section between like all the cross sections. Then take the average slope. Okay, assign that slope as a normal depth. Means at the downstream condition. Okay, understood how to take? So it was an average 0.02. Okay, you just click here. Normal depth. Click on normal depth. I told you, right? At the downstream, if you have the stage hydrograph, you can give stage hydrograph. If you have the flow hydrograph, you can give. But as of now, we don't have the water surface level and the flow hydrograph at the downstream. So you are going with the normal depth concept. If you have the rating curves also, you can give the rating curve. Normal depth. So it will ask you to mention the friction slope. Okay? Just mention 0.02. It was the average slope. I just showed how to calculate the slope. Okay, you just enter the value. I just showed how to calculate the slope. That's it. That is how you need to calculate. By mistake, if you have given flow hydrograph downstream, so you just again you can modify it. Click same, choose normal depth, and give slope at the downstream. Again same way. Upstream station you will select up flow hydrograph. Units it will calculate. It's not this is friction. Automatically it will iterate with the alternative equation will come. Different conditions. Yeah. That is nothing but depth. The difference if you do flow, that is direct depth. It will take direct depth.
Yes, sir.
It is friction. Friction slope. Frictional slope. It's a frictional slope. That's it. Bed slope. They are assuming that is it.
Section is
Any doubts? Any clarity missing? What? Okay. Anyway, I will show you. You don't need to do that. But when you are doing for real case, that is the way. You take ahead 10 kilometers or 5 kilometers, identify the slope, then take the average of all those. Then you can assign those values. I will just show you how to calculate again slope. Okay, go to RAS mapper. Here the scale is there. For example, I am showing from here to here. Just double click it. It will show you the slope. Again, the same way, calculate slope from here. Again, you calculate it. Like that, we are finding the average slope. Okay, and we are assigning that value at the downstream. Okay. By mistake, if you are given flow hydrograph here, normal depth here, modify it. You can modify it. Okay. Till now clear? Up to this done, right? No doubt. So with this, all our input is done. Now we will run. Just save it. Save unstudy flow file. Unstudy flow data. Just name it as unstudy. Name it as unstudy. And click OK. So here it will be up here. You can close this.
Initial condition is not required. As it is on the table.
Actually, initial conditions are not required. If you have, you can do. If the data is there, it is. Yeah, if the initial condition values are there, you can do. But it will automatically by default value the predicate. If we have the information, we can do it. So after that, we need to run the unstudy flow. So to run that, just save it once. Click on run. Click on run. click on unsteady flow analysis. It is like our control panel. Here we need to fix the time interval. Okay. So it has to run, it has to take geometry processor, unsteady flow simulation, post preprocessor, and flood. It has to create the map also, floodplain mapping also. So check all those. And then here you need to give the interval. Our event date is 23rd July, right? 23rd July to 22nd August. So from this calendar, you just select that 23rd July to 22nd August. 23 July to 22nd August. Our starting time interval was 24:00. Our ending was 00. And make all the intervals, computational settings, 1 hour, 1 day. After that, just make it all in 1 day. Okay. Then it will, all this information will be stored as plan 01. Okay. Then just click on compute. Click on compute. If any errors come, now it will show. Yeah, all computational settings will be 1 day. Just click on compute. After that, incomplete. Incomplete. Anyone getting error?
Yes, sir.
Those days are total 31 days. Error? Anyone getting error? Positive flood area. But it can go external. But cross section it won't go beyond cross section. All of you reading all of you clear here? So all done, right? Now we'll see how the flood inundation is happening. Just close this. Close this. Close this. Open RAS mapper. Open RAS mapper. is the. So just here you can see in the results, plan 1 is there, right? This is our saved plan. So just click on depth. Just choose the depth. Check that is depth. Okay. So now you can see this is the how the depth is changing throughout the event. Okay. You can see how the depth is changing throughout the event. If you click here maximum, what is the maximum extent of flood? Flood inundation. So, one important observation here, I told you, right, whatever the cross section we have drawn, water cannot move beyond that. Okay, see here in this case, my cross section is up to here, that's why flood came, it is showed up to here. If I drawn up to here, so flood might happen here also. So while drawing cross sections, how to draw in such a way that you should draw the long parts, long lines, so that it will go all over the wherever the possibility is there. Okay? This is the flood inundation map. You can attach this to satellite map. Just click here, Google satellite. Then you can see the real case. What zone is in critical. Okay? Yeah. Yes. Then after this, if you want to validate this, NRSC people will give you the flood inundation map. So that you can take, and this you can take. These two rasters, you can correlate it, you can identify the evaluation, performance. Okay? If you want to export this, you can export. In the same way, you can see the velocity, how the velocity is changing, and also you can see the water surface level, how the water surface level is changing. So all, I told you, right, all these three are the inputs from the hydraulic model. All of you got this flood inundation map? So if you want to export this as a raster, just click on this plan 1, right click on this plan 1. Here create a new results map layer. Here it will show you the rasters, what are all there. You can just click on depth. Here you choose the format. Raster only. Yeah, just keep it the same. Then add map. So successfully added. It will be there in the project folder where you have saved project, right? In that the raster map is there. You can add, you can open that raster map in QGIS. Okay? All of it clear? So this is for unstudied flow data, right? Generally, real case is unstudied flow only. Suppose if you want to see, for example, my peak is 15,000 meter cube per second. If I want to see how much area will be in inundation, then you can see that this comes under study flow. So to do that, again you need to create study flow. I will show you.
One by one.
Daily layer కావాలి అదే
So this is unstudied flow data. If you want to check for any study flow, means if you want to check for any peak flow, how that flood inundation is happening. So for that, go to edit. Go to edit. That comes under study flow data. Study flow. Here you directly give the flow value. For example, you want to check at 20,000 meter per second. Just type that 20,000 and save the study flow data. Just click on file, save it, make it as study. Just I am giving study flow. Click OK. Go to file, save the data. Okay, then close this. Yeah.
Sir, now I have to get that again of the
Yeah, just name the
what is the
study flow. So to run for the peak, go to edit, click on study flow data, give the flow here, and then go to file, save it with the name study flow data. Okay, then close it. See here in the study flow it is appear. Okay. Yeah. Okay, all of you reach here. Up to here reach here. Doubt is there, you ask, then only I will come. Go to edit, study flow data. CS that space and enter 20,000. Still it is not coming. This is 24 after 1 2 minutes hour you have change it to direct. Now see 23, 24, started from 23, this value of August 23. Maria,
Two step, one step ahead.
Yeah. So now you need to run the study flow. Now you need to run the study flow. It's already all of plane based computer. Which one is missing? Boundary condition. Here we forgot to give upstream and downstream condition in the study flow, right? So here you have to mention upstream was what?
Go back again and show this one.
Please repeat this one. Please repeat the steps. Yeah. So what I am telling is, if we have the peak flow, for example 20,000 meter cube per second. Now see at that 20,000 meter cube per second, what is the inundation area? Okay. For that, just go to edit, study flow data. Okay. In this, here we forgot, the last time we forgot to mention the boundary conditions. Say the upstream mentioned 20,000 meter cube per second. Here it will automatically take it from the here 20,000 meter per second, but here you mentioned the downstream normal depth 0.02, click OK.
रफी देखना ऐसे है
Reach boundary condition.
ओके राइट
Okay, just click OK.
Sir,
Normal depth.
sir, I put the value on
अपस्ट्रीम है
Upstream, I think it will take it from here. Here, 20,000 meter cube per second. Let's see. It is not coming here.
डाउनस्ट्रीम we have to write
Downstream here.
we have to write
Normal depth.
we have to write
Same concept. Right? Just click on normal depth. Here you mention the slope.
yeah
It will automatically come here.
0.0
Yeah. Click OK. Just let's see. Go to run. Study flow analysis. Click on compute. It will run. Okay. So for the same flow, yeah, it is subcritical flow. Why? Because it is a gradually varied flow. So the water is not suddenly changing. Water was gradually varied. If it is any in between any structure is there, then it will become supercritical. Until that structure will be, yeah. So until that it is, we are assuming that water generally flows with the gravity. So it is a gradually varied. Flow is gradually get saturating. Now, sediment data we are focusing on sediment. I need some information related to sediment. We are not here. Yeah, we will also get sediment. Now we can see there are so many options in HEC-RAS. We have seen just 1% of it. So many other options are there. You can explore it. There is a manual is there in the HEC-RAS website. It is not only used for flood inundation, it will also use it for sediment, so many other purposes. Okay, this is one way to get the inundation map. Okay. Now let's see with this 20,000 meter cube per second how the flood inundation map is changing. Click on RAS mapper. Okay, in the plan 2. See, now it got extended, right? It was more compared to the previous. Yeah, it is not changing with respect to time, it won't change.
Sir, I can see it.
Yeah, you can see. There is option called 3D. If you want to see, you can click OK. You can also see in 3D. I think some systems will support, some systems don't support. It is just a 3D view. How the cross section is there, how the water is flowing, all those visuals visible. That option. It's okay. Okay, it is done. So with this HEC-RAS is completed. You practice it one more time today, the night. If you have any doubts, I'll be here. You can ask me. Okay? If the 20,000 meters per second is constantly exposed throughout the cell, because there is study for it, it's not changing meters per second. Because it is only one thing. Same on this one. Inundation వస్తుంది. స్నాప్ చూసారు కదా, స్నాప్ ఇందులో స్టేజ్ ఎక్స్ప్లోర్ లేయర్స్ పెట్టి ఆ లేయర్ నుంచి ఏరియా కనుక్కోవాలి. అటు ఇక్కడ So all of you reached up to here, right? Okay, we'll close it. We'll close with this. Tomorrow, sharp 8:30, you come at Kalamar.
to step, what step ahead?
Yeah. So now you need to run the study flow. Now you need to run the study flow. It's already all of plain just computed. So which one is missing? Boundary condition on the screen. Here we forgot to give upstream and downstream conditions in the study flow, right? So here you have to mention upstream was what?
Go back and show this one. Please repeat this one. Please repeat the steps.
Yeah. So what I am telling is, if we have the peak flow, for example 20,000 meter cube per second. Now see that at that 20,000 meter cube per second, what is the inundation area? Okay. For that, just go to edit, study flow data. Okay. In this, here we forgot, the last time we forgot to mention the boundary conditions. Same, the upstream mentioned the 20,000 meter cube per second. Here, it will automatically take it from the here, 20,000 meter per second. But here you mentioned the downstream normal depth 0.02. Click OK.
रफी देखना ऐसे है
Reach boundary condition.
okay right
Okay. Just click OK.
Sir,
Normal depth.
sir, I put the value for
upstream and
Upstream, I think it will take it from here. Here, 20,000 meter cube per second. Let's see. It is not coming here.
downstream we have to write
Downstream here.
we have to write
Normal depth.
we have to write
Same concept. Right? Just click on normal depth. Here you mention the slope.
yeah
It will automatically come here.
0.0
Yeah. Click OK. Just let's see. Go to run. Study flow analysis. Click on compute. It will run. Okay. So for the same flow, yeah, it is subcritical flow. Why? Because it is a gradually weighted flow. So the water is not suddenly changing. Water was gradually weighted. If it is any in between any structure is there, then it will become supercritical. Until that structure will be, yeah. So until that it is, we are assuming that water generally will flow to gravity. So it is a gradually weighted. Flow is gradually weighted. Subcritical. Now, sediment data we are focusing on sediment. I need some information related to sediment. Now you can see there are so many options in HEC-RAS. We have seen just 1% of it. So many other options are there. You can explore it. There is a manual is there in the HEC-RAS website. It is not only used for flood inundation, it will also use it for sediment, so many other purposes. Okay, this is one way to get the inundation map. Okay. Now let's see with this 20,000 meter cube per second how the flood inundation map is changing. Click on RAS mapper. Okay, in the plan 2, see now it got extended, right? It was more compared to the previous. Yeah, it is not changing with respect to time, it won't change.
Sir, I can see it.
Yeah, you can see. There is option called 3D. If you want to see, you can click OK. You can also see in 3D. I think some systems will support, some systems don't support. It is just a 3D view. How the cross section is there, how the water is flowing, all those visuals visible. That option. Yeah. It's okay. Okay, it is done. So with this HEC-RAS is completed. You practice it one more time today, the night. If you have any doubts, I'll be here. You can ask me. Okay?
If the 20,000 meter cube per second is constant, he explodes throughout the cell. Because there is study for it, it's not changing with respect to time. Because it is only one thing. Same on this one. Inundation వస్తుంది. స్నాప్ చూసారు కదా, స్నాప్ ఇందులో స్టేజ్ ఎక్స్ప్లోర్ లేయర్స్ పెట్టి ఆ లేయర్ నుంచి ఏరియా కనుక్కోవాలి. అటు ఇక్కడ
So all of you reached up to here, right? Okay, we close it. We close with this. Tomorrow, sharp 8:30, you come at Kalamar.